Okay, here we go. 2.2, another short lesson here. We're going to solve inequalities using addition or subtraction. And I am recording this while on vacation in Lake Norman, North Carolina. Just got finished with my family doing some wake surfing, wakeboarding, and I didn't water ski, but the kids and my wife, who's an expert water skier, did. If you come up with a piece of interesting information about Lake Norman, North Carolina, and email it to me tonight or today, depending on when you're watching it, I will give you a point of extra credit homework. Homework extra credit. How about that? Lake Norman. Okay. Go ahead and solve these equations as a warm up. And again, think about what you need to do when it's absolute value. Because, right, we want what's in the absolute values can be equal to 7 or negative 7. Okay, give them a shot. Okay, so we're back, and hopefully you just subtracted 5 from both sides and got negative 20. And of course, you could plug in to check. Negative 20 plus 5 is negative 15. And here, in order to write this as two linear equations without the absolute values, you would write them like that, right? Again, like I gave you in that hint, we want 3 minus x equals 7, or 3 minus x equals negative 7, and then you need to solve for x in both situations. So in this one, hopefully you subtracted 3 from both sides. You got 7 minus 3 is 4, or 7 combined with a negative 3. And here we don't have x yet. We have the opposite of x, or negative 1x. So you can think about it as dividing both sides by negative 1, or you could just say, wait, if the opposite of x equals 4, then x itself must equal negative 4. And here we're going to subtract 3 from both sides, or add a negative. Remember, two negatives, when we're combining those, we take the sign and add their absolute values. So take the negative, and 7 plus 3 is 10, so we get negative 10. And if the opposite of negative 10, or an opposite of x is equal to negative 10, then x itself is 10. Okay, our learning target here will be to be better able to use addition or subtraction to solve and graph inequalities. All right. Now, this is a very interesting little exercise that you may want to work on with someone who's a big football fan in your family. And the NCAA, so we're talking college football, uses the following formula to rank the passing efficiencies, capital P, of quarterbacks. Okay, so like if quarterbacks, it's a way to quantify, to give a number on how well a quarterback's playing. And you can see that what the various variables represent. Y is the total length of all completed passes. So in other words, the more passes that are completed, like thrown to a receiver and caught and they get yards, the better. Makes sense, right? C is the completed passes. T is touchdown passes, which is huge, right? Obviously, you can see it's multiplied by 330, where rather regular completion is just multiplied times 100. N is intercepted passes. That's when the other team gets it. That is not a good thing. So you can see why it's minus 200N. And A is attempted passes. Okay. So, and M is incompleted passes. Okay. And you can see that that's not part of the formula. Can you think of why? It's because if they're only taking into account here, if we're taking into account, right here, for C, completed passes out of attempted passes, then there's no reason to have incomplete passes as part of the formula. It's factored in by the fact that it's completed divided by all attempted passes. Okay. So go ahead and try this. Think about whether these are possible. If you're not a sports fan and you want to just skip this, feel free, but it's kind of fun. Okay. So determine whether each inequality must be true. Explain your reasoning. So here it's saying, is the number of passes resulting in a touchdown less than, does it have to be true that it's less than the number of completed passes? The answer is no. What would be a scenario where that would be true? Well, what if a quarterback only threw 2 passes in a game and then got hurt, but both of those passes went for touchdowns, then the number of touchdown passes would not be less than, it would be equal to. Okay, what about the number of completed passes plus the number of intercepted passes? Does that have to be less than or equal to the number of attempts? The number of attempted passes. And the answer there is yes, of course. It's got to be, right? It could be the same, but it can't be more than that. Okay, what about the number of intercepted passes as compared to attempted passes? Does that have to be less? The answer there, no. And that would be a situation of when quarterback threw like 1 pass and it was intercepted, and that would be 1 intercepted pass, 1 attempted pass, so they'd be equal, would be less than. Okay, and then what about A minus C greater than or equal to M? So the number of attempted passes minus the completed passes, does that have to be greater than or equal to the number of incomplete passes? The answer obviously is yes. Okay. All right. And the reason it could be equals easy, right? You could see that like attempted minus completed would equal incomplete, or it could be greater because remember you could have a pass intercepted, which means that A minus C would actually be greater than M. All right. If you really want to take it to the next level, you can use the passing efficiency formula that we just talked about to find a scenario where the passing efficiency is less than 0. So I've put the formula again down here so that you can see that. So think about what would make this negative, right? If we're basically combining all these 4 terms up here together, what's going to make it negative? If n is a big number, right? So think about what that would look like. Go ahead and try that. Okay, so let's see here. My scenario was 1 attempted pass, 0 completions for 0 yards, 0 touchdowns, and yes, the pass was intercepted, right? Because that means that 8.4 times 0 would be 0, 100 times 0 would be 0, 330 times 0 would be 0, and negative 200 times 1 would be negative 200 divided by a, which would be 1, and that would be a negative. Okay, what about this one? P minus 250 is greater than negative 80. Well, that doesn't really tell me what P is. I had to solve for it. So I'm going to add 250 to both sides, which means that P needs to be greater than 170. So this is a situation where a quarterback's done pretty well. So what is that going to mean? What's going to bump this up to make it, a big number? Well, we don't want interceptions, right? And we probably want a lot of touchdown passes. So I did 10 attempts, 7 completed. It's a good percentage, 70%. Any quarterback would take that. For 300 yards, 2 touchdowns, and how many interceptions do you think? Ooh, I went with 1. And gosh, we'd have to plug this in. But that's still pretty good game for a quarterback. It's a very good game. 300 yards passing. Usually they say a 2-to-1 touchdown to interception ratio for a quarterback is good. And anything above that is great. So that would work. All right, a little fun with that. All right, so here's our core concept, addition property of inequality. Basically, if we're adding the same number to each side of an inequality, that's going to produce an equivalent inequality. Okay? So here's some examples. If we have negative 3 is less than 2, and we decide to throw 4 onto both of those sides, that's going to become 1 on the left side, and the right it's going to become 6. Is it still true? Is 1 less than 6? Absolutely. And then here's another one with negative 3 greater than or equal to negative 10. Remember the negatives, you got to be careful. What looks smaller is actually bigger. So we add 3 to both sides. We get 0 is greater than or equal to negative 7. True? Absolutely. Okay, if you're looking at it in algebra, if we have A is greater than B, if we add the same thing to both sides, in this case C, you can see, get it, see, that it's still going to be true, right? If, let's say A was 5 and B was 4, 5 is greater than 4. If we added 2 to both sides, is 7 greater than 6? Absolutely. And that's going to work with all 4 of our inequality symbols. And that's all that shows there. Okay, so I want you to solve x minus 6 greater than or equal to negative 10 and then graph it so we can get a little practice with that. Go for it. Okay, so obviously we're going to add 6 to both sides. We're going to get our equivalent inequality of x is greater than or equal to negative 4. Remember graphing 3 important things. What's your key point? Open or closed, and then which way does that arrow go? And in this case, hopefully you did a key point was negative 4, filled in. I don't know if that really shows that it's filled in, but it's filled in. And where are the numbers that are greater than or equal to negative 4? To the right. Okay, go ahead and try these. So obviously we would add 2. And what would your graph look like? You're going to have an open dot on negative 7 and graph to the right. And again, when you check these, you can really check the same way. A couple ways, really. You could plug in negative 7 and say, okay, negative 7 minus 2. Does that get me the same number that's on the right side? Yes, negative 7 minus 2 is negative 9. And you might be saying, but yeah, but it says it's less than. That's true, but remember, we're not including that point. So that just tells us that we have the right key point. And then you still got to do the open circle on the right. Now, you can always plug in a number that's greater than negative 7 from your number line, so like negative 3. If you plugged in negative 3 to the original, negative 3 minus 2 is negative 5. Is that greater than negative 9? It sure is. Okay, fractions are our friends. Go ahead and try this one. Okay, so hopefully you added 1/4 to both sides. 1/4 plus 1/4 is 2/4. That's not how we'd want to write our answer. We'd want to write it as 1/2. Now careful, y is on the right side this time. So key point obviously is 1/2. Open or closed? Open. Left or right? Actually left, right? We want numbers that are less than. By the way, this bar here is just saying that's where 1/2 is, just like you have these bars up here. So that you can see it's an open circle. Okay. Subtraction property of inequality, it's basically the same thing as what we just talked about, just that if it's subtraction, you subtract the same thing from both sides, it's going to work with the 4 inequalities. I think that's probably all we need to say on that, because isn't subtracting a negative the same as adding, subtracting a positive the same as adding a negative? It absolutely is. So the same rule would apply. So here, again, you can think of it as subtracting 8 or adding a negative 8 to both sides. So 5 and negative 8 is negative 3. We're graphing this. And it's totally fine to graph like this. I don't really care, if you put other numbers on there. I know that by doing it this way, it means we're going there. Okay, and then here we're going to subtract 1.4 or add a negative 1.4, and how you want to think of it. And you can see I had my number line there, but I've bolded in this side, and again, open, because we're not including negative 9.4. All right. Think, pair, share if you're working on with this with somebody. Go ahead and solve and graph. So again, you would hopefully you subtracted 3.8 from both sides. Again, negative and a negative. If we're thinking of combining, we take the sign and basically add the absolute values. And what's your graph look like? Hopefully it looks like that. Okay. Here, you're going to add 3/4. What do we need to have in order to combine those two fractions together? You got it. A least common denominator, which is what for 5 and 4? 20. And now we can combine them together. Remember, don't add those denominators together, right? And again, 23 over 20, fully reduced. You don't need to change that to a decimal. If you're dying to do it, go ahead and waste 3 seconds of your life, but that's okay. It's your life. And then we go and we graph it. All right, and let's do a word problem here using this. A circuit, oh wait, let's go to our happy place. Okay, Mr. and Ms. Word problem, I'm going to solve you now. We've done enough of this now. Hopefully you're gaining confidence with your word problems. A circuit overloads at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. Okay, assign and define a variable. Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. And yes, I understand you probably can look at this and say, oh, I know what the answer is. But I want you to practice assigning and defining a variable, in this case, writing an inequality and then solving it. Okay, so what's unknown here? Yeah, the number of additional watts. Okay, and what would be an inequality you can set up? Well, we know that it overloads at 1800, right? So 1100 plus W would overload it, right? So we've got to have W plus 1100 to be less than 1800. And then solving it, obviously, we're going to add negative 1100 to both sides, or subtract 1100, whatever you want to think of it. And we know we have to label our answers for word problems less than 700 watts. Okay, B says, in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading the circuit? So, and here's how many watts each of these items have. Like, what could you plug in? Clock, radio, blender. Could you plug both of those in? Yeah, because that's less than 700 combined. Can you do any other combo? Absolutely not. Okay, and I think that is it for 2.2. So enjoy. And I'm going to go back to enjoying Lake Norman, and I will see you guys soon.